Surface improvement of additive manufactured parts is not an option. Abrasive flow machining, known as AFM, is one of the most efficient processes for improving the surface finish of metal parts, including those produced by additive manufacturing. The AFM is suitable for AM part finishing, delivering up to 10 times or beyond surface roughness improvement. But with the latest generation of dedicated abrasives, it became even more efficient. Hello, I'm Brian, the U.S. Business Development Manager for Contract Shop. Extrude Hone has supported the development of additive manufacturing since day one. It's not only that we are interested in offer finishing, we can also help define the right balance between the quality of construction, the time spent in the building phase, the roughness of the AM outcome, and the time allocated to the finishing operation. As we process thousands of AM parts and work with machine builders and key customers across multiple industries, we have developed extensive expertise in tackling the most demanding applications. In this video, I will process an AM impeller. I'd like to share some key elements about the AM parts we see. First, the materials include Inconel, titanium, aluminum, steel, and stainless steel, like the impeller we process, which is 316 stainless. Second, the incoming roughness, which ranges between 100 RA and 600 RA microinch. In our case, the impeller roughness averages about 130 RA. The AFM process can bring it under 20 RA. In our example, we went down to a 13 or better. In some industries, such as semiconductors, we are challenged to go even further below. We process the AM parts using different machines based on component size. Our machine portfolio starts with a small EcoFlow, then an EasyFlow, and finally the VECTOR machine we see in this video. Ultimately, we have the spectrum range of products for our very large components. Depending on their configuration, these machines have different media volume capacities, ranges that must match the AM overall section to be processed. But before we dive in, let's answer a simple question. How does AFM work? Three elements underpin abrasive flow machining: the machine, the fixture, and the media. The machine extrudes the media either in a two-way or one-way flow through passages formed by the workpiece itself by a fixture. When the media circulates, the abrasive action is greatest in the most restrictive passages, which offer the greatest flow resistance. The fixture's role is to handle the part and to drive the media to the targeted areas. It can be simple or complicated. Understanding fixture design is key to optimizing the application or increasing productivity. But that's not all. The media is at the heart of the AFM process and the most important element. To make it simple, the media is like silly putty loaded with abrasive grit. The viscosity, the size, and the concentration of the grit, like their nature, can be multiple. The specificity of the media as a non-Newtonian lies in the high coefficient of restitution. Cold flows at rest, but acts like an elastic solid under stress. Rather than a one-size-fits-all putty, your component's media should deliver predictability, uniformity, and purity for a better cut and extended media life. We have 62 unique polymers and about 100 abrasives to build the recipe you need for your application. Among them are specific to additive manufacturing because the AM materials are often exotic and demanding because of more intricate geometry. Organic passages represent a challenge because the difference between roughness and between the upper and lower skin also adds complexity. We needed a media evolution that would allow us to address all of these points. Our specific AM media portfolio is based on the latest developments in abrasive technology to deliver optimal performance. Knowing all this, let's focus on the benefits of AFM. 1. Adaptivity. Suitable for organic and complex designs that are often out of reach for traditional methods. Because of the nature of the AFM process, the media putty is forced through the AM component passages. By doing so, it follows the natural end fluid path. Number 2 is flexibility through various tooling solutions. Works with or without tooling, depending on part design. Open parts would require enclosing the part in a fixture, create a restriction between the artificial wall and the surface to be processed. Think about an open impeller. A closed passage, such as that is found in a manifold or closed impeller, would most of the time require no fixturing or only minimal fixturing to drive the media in and out of the part toward the machine media cylinders. Think about a manifold where a thread could be used to connect hoses driving the media in and out. Number 3 is productivity. The AFM process is suitable for processing either a single component or multiple ones at once, depending on its design and size. Optimized AM media using new abrasive technology will drastically reduce the processing time, offer a competitive time cycle. Spend less time building a part with already improved roughness. Instead, leave the AFM process to enhance your roughness by a factor of 10 or more. Number 4 is accuracy and process stability. Everything is under control, as the machines are equipped to regulate the parameters that matter in the AFM process, such as media pressure, temperature, and extruded volume. Dynamic automated controls and adjustment of all these parameters are provided by our AutoFlow solution. Reduce the surface roughness to less than 10 RA on the small hole section. The latest media technology is more effective at targeting the downskin. One aspect of AFM is its cleaning power, which removes particles trapped within the part, especially in the intricate channels of conformal cooling, without impacting the surface, as the removal rate is controlled. Cleaning is an added benefit. The cleaning after AFM and how to ensure a safe result. Some people may wonder if AFM could be risky, as some media could stay in the AM part. Well, the answer is that there's no risk once you apply the appropriate post-AFM cleaning strategy. Think about precise machining using traditional CNC means. Burrs and chips must be removed, right? For the AFM, a powerful blowing step is usually sufficient to remove the media. To meet enhanced cleanliness requirements, we recommend ultrasonic cleaning to ensure no trace of abrasives remain. Some enhanced chemistry and temperature-elevated targeting the carrier might also be useful for demanding application, such as in the medical field. In the most current application, a suitable cleaning strategy is quickly implemented, yielding satisfactory and compliant results. Extrude Hone sells AFM machines, but what else do we offer to the customers interested in AM finishing? We provide consultancy to develop the best manufacturing strategy, find the right balance between build and finish, but anticipate how the design may impact the finishing. We are offering contract work. We receive your part, process them, and return them to you in all regions around the world. We sell the complete solution: machines, tooling, pre- and post-treatment units for customers who want to start producing parts in-house. We design and build tools and media for AM applications and provide service and spare part support to our customers. That's all I have for you today. I hope you've enjoyed the video and I have answered some critical questions about AFM. If you would like to learn more, please visit our website at extrudehone.com for additional details and to contact us.